Hey guys, we're back again with another example of a geometry proof that this one is a little bit different in that it's requiring us to prove not that segments are congruent or not that angles are congruent, but that there's two segments here that have a particular relationship and that they're perpendicular. Now the first thing that we're going to do is I'm going to skip over the first step of actually rewriting all of the given information. So what we're going to do is we're just going to jump right into that AB here is the exact same thing as AD, and we're also told that BC is the exact same as DC. Now, from this, what we're actually going to have to do is quite a good bit of congruent triangles. So the first thing that I'm going to do here is I'm going to say, well, if I look at this triangle DAB, you can see that there's two sides of that triangle that are congruent, and so by the hinge theorem, or by the fact that this is an isosceles triangle, I know that these two angles right here are congruent. So really, my second statement here is just simply going to be that angle ABD is congruent to angle BDA. And you can say by hinge theorem, you can say by the isosceles triangle theorem, base angles, any of those theorems will work here. But basically the important thing is we need to get that these two angles right here are congruent. Now from there, what I'm going to do is I'm going to go to another similar idea, which is I'm going to look over at this triangle here, DBC, and I'm going to say the same thing about these angles here in green. And for the same reason. So basically, step 3 here, we just said was angle XDC is congruent to angle XBC. And same reason, hinge theorem, base angles, take your pick on that one. Now from this point, what I'm going to do here is I'm going to say, okay, well, if we look at this red angle and this green angle here, this red angle and this green angle here, then I can kind of say, well, this large angle is the same as this large angle, which makes this triangle completely the same as this triangle down here. And as I'm looking at this, I'm kind of going, well, does that really help me that much? And as I'm looking at this, I'm going, actually it does. Here's why. If you look at this triangle down here, so I'm going to say step 4 here is this angle right here, the red angle, which is angle A. Let me rewrite that so we can say ABD plus angle XBC has to equal the large angle ABC. I also can see that the angle BDA plus the angle XDC has to equal that big large angle ADC up here. Well, my number 5 here is, well, if I can show that this angle is the same as this angle here, which I did in step 2, and this angle here is the same as this angle here, which I did in step 3, then that means that this angle has to be the same as this angle right here. So I can say that angle ABC has to be congruent to angle ADC through angle addition. Angle addition. Now at this point, what I've done here is shown that this big triangle here, ABC, is the same as ADC. And I need to say that in the form of a congruency. So I'm going to say that triangle ADC is congruent to triangle ABC. And the reason for that is I have a side, which is this side with one tick mark, an angle, and then another side, which is the side with 2 tick marks. Now, this may not seem helpful at first, but what this does is it lets me say the following about these smaller triangles right here. This angle right here which is angle DAC, is going to match up. If I say angle DAC, it's going to have to be congruent to angle BAC. And if I look at BAC, that's this angle right here as well. Okay, and because I've already marked these angles down here in brown, I'm actually going to mark those up in red so that I can really get them to stand out here, and so that we can see that those angles are completely different than the brown angles. So I'll even add another extra arc right there. Well, what I've done here now is if you look at these triangles right here, I'm going to highlight them very carefully here. This triangle here, and this upper triangle right here. If you look at these triangles, essentially what's happened here is I've gotten an angle with a side, and then an angle, and then down here I have an angle with a side and an angle. So really, by creating these two congruent triangles and establishing that these angles are the same through CP, CTC, corresponding parts of congruent triangles are congruent, what I've done is I've also created these two smaller congruent triangles. So if I just slide my work over here and pick up, so I'm leaving off from step number 7, which is really the step right here, and that reasoning, and I'm sliding over here to step number 8, what I want to say now is that these two triangles right here are congruent. And the way that I'm going to do that is by simply saying that triangle ADX must be congruent to the triangle ABX. And you can see that just by following your order of the markings here. I went from the red angle up the tick mark to D, then down to X. So start at the red angle, follow the tick mark to B, and then go down to X. So why I can say that is because of the angle side angle congruency. Angle side angle congruency. Now from there, what we can see here is this angle right here, angle AXD. Angle AXD has to be congruent through correspondence with the other triangles. So if I look at this, AXD should match up with angle AX, so AXB. And if I look at angle AXB, that's this angle here. So coloring those in purple here, this angle here, AXB, should be the same as this angle here, AXD. Well, because these form a straight line, that means that they also have to add up to 180. So looking at this, angle AXD plus angle AXB must equal 180. And the only way that this can happen, since both of these angles are equal, is to say, well, if this angle is equal to x, I can say that that's x. Well, we already have the letter x, so I'm going to say let angle AXD have a measure of, we'll say, W, because we haven't used W yet. Well, what that means is that W plus W must equal 180. Well, the only way that two W's added together can be 180 is if W equals 90. And there's some algebra that you can go through there. I'm not going to take you through all the algebra. But at this point, because W is equal to 90, that means that these two angles up here both have to be 90 degrees. Well, if those are 90 degrees, then that means that this must be perpendicular. So by definition, we've shown that these are now perpendicular. So our final statement here is to say that angle AXD is 90 degrees. Thus, angle AXD is a right angle. And because of this, the two segments that we wanted to prove that were perpendicular, which were segments AC and BD, must be perpendicular. So I hope all of this helps. I know that that was a fairly long, involved proof that kind of spanned a lot of different relationships here, but the key here is, once again, to get these triangles to be congruent so that you can get these angles here to be congruent, and then use those similar angles right here in purple to show that those lines are perpendicular. I hope that helps. If you have any questions, feel free to give me an email. My email address again is drenniemath@gmail.com, and I hope you enjoyed the tutorial.